So now we're going to look at logarithmic functions. So a logarithmic function to base a is the inverse of an exponential function to base a. So you can see on this graph I have plotted the y equals a to the x exponential function going through the points 0, 1 and 1a. If we reflect that logarithmic function in the line y equals x, we get the inverse function, which is y equals log to the base a of x, and it goes through the points 1, 0 and a1. And it never crosses the y-axis. So you can see that when a is greater than 1, it is an increasing function, and the y-axis is our asymptote this time. If our base a lies between 0 and 1, the graph is decreasing with the shape, and so this time it will go through the points 1, 0 and a negative 1. So the first example, the graph below has equation y equals log to the base a of x, and we want to find the value of a. So first of all, we need to consider our key points on our logarithmic curve. And those would be 1, 0 and a1, where a is our base. So you can see here, for our y equals log to the base a of x, our points are 1, 0, which ties in, and 3, 1. And so our value of a is going to be 3. So a equals 3, and if we wanted to write our curve as our equation, it's y equals log to the base 3 of x. In the next example, the graph below has the equation y equals log to the base 5 of x minus a and passes through the point b1, and we want to find the values of a and b. So again, we want to think about what would our graph of log to the base 5 of x look like. So our log to the base 5 of x curve is going to go through the points 1, 0 and 5, 1. Now our log to the base 5 of x minus a curve is going through the points 4, 0 and b1. Now, if we look at what happens to our 1, 0 coordinate, it's being shifted vertically 3 units to the right. Because our bracket is an x minus a, it means our a value is going to equal 3, because we've got our vertical shift 3 units to the right. Now, if we apply that to our 5, 1 coordinate, we've got b equals 5 plus 3, so our b value is going to be 8. So it means that our equation is going to be y equals log to the base 5 of x minus 3, and that coordinate is going to be 8, 1 on our curve. Our final example is to sketch the graph of y equals negative log to the base 3 of x. Now, when the negative is in front of our function, it means that we're reflecting in the x-axis. So again, let's consider our log to the base 3 of x curve. It's going to go through 1, 0 and 3, 1. So our negative log to the base 3 of x curve is going to go through 1, 0 because it's on my x-axis, but my 3, 1 is going to go to 3, negative 1. So if I plot those points on, I've got my 1, 0 and I've got my 3, negative 1, and I'm just going to write those values on. And then I'm going to sketch my curve. Remember, it's approaching the y-axis, but it's not actually going to go through it. And then finally, I'm going to label it as y equals negative log to the base 3 of x.